Consider an acute angled triangle ABC. Given that tan A tan B plus tan B tan C plus tan C tan A equals 9. Find angle A. Try it for 1 or 2 minutes, then move towards the solution. I hope you give it a fair try. Before moving on, from a basic property of triangles, something all of you must know. The sum of angles of a triangle is 180 degrees, or pi radians, as written on the screen. Now let's move C to the other side, and take tan on both sides. Then we end up getting tan of A plus B as tan A plus tan B, over 1 minus tan A tan B, and that equals negative tan C. Now we move the denominator, 1 minus tan A tan B, to the other side. Opening the bracket, we get something like what you see on screen. Taking tan C to the other side, we end up getting a beautiful result. The sum of the individual tangents equals their product. Please note, this identity is true for all triangles. Now applying AM, GM on tan A plus tan B plus tan C, we get that the sum is greater than or equal to 3 times the cube root of their product. Since the sum equals the product, we substitute and simplify step by step as shown on screen. Since the product equals the sum, we substitute. The right side becomes 3 times the cube root of the sum itself. So the sum to the power 2/3 is greater than or equal to 3. So the quantity tan A plus tan B plus tan C raised to the power 2/3 C is greater than or equal to 3. Now raise both sides to the power 3/2. The sum is greater than or equal to 3 to the power 3/2, which is 3√3. That is our lower bound. Good. Now we bring in the given condition. Tan A tan B plus tan B tan C plus tan C tan A equals 9. Now we will apply AM, GM on these 3 product terms. So we have tan A tan B plus tan B, tan C plus tan C tan A equals 9. This is our starting point for the second inequality. We simplify a little bit. Tan A multiplied by tan A equals tan squared A, which is written on the screen. Now let's do a little bit of algebra, and we end up getting tan A tan B tan C is less than or equal to 3√3. Now, let's put it all together. Across all the slides, we ended up with 2 inequalities, pointing in different directions. Both equalities can only hold at the same time. If 3√3 equals tan A plus tan B plus tan C, this implies tan A equals tan B equals tan C. This comes from the equality condition of the AM-GM inequality. Please note this carefully. Since it is an acute angled triangle, the tangents of all individual angles are positive, and since all tangents are equal, all angles must be equal. This means each angle must be 60 degrees. So this is an equilateral triangle. And that's it, proved.